This is the lecture for lesson 17. This lecture is going to be all about transformations of our functions. So we'll start with describing transformations of graphs. The following table lists a lot of different ways that we can translate or transform our function. The original function is the f of x piece, and there's all sorts of different things that we can do. So this first one, if we just put a plus d or some plus number on the end, it means we're going to translate up that many units. If we subtract a number on the end, that means we're going down so many units. If inside of the parentheses is a positive x plus c, we are moving left c. If it's a positive x minus c, we're moving right c. A negative outside of the function reflects over the x-axis. A negative next to the x reflects over the y-axis. But do note that this I need to be careful with, because if it's f negative x plus c like this, I have to be careful because this is not one that's listed here. And it's not just, oh, this and this one. We have to look at it as it's the opposite of everything. So this is actually the opposite of x minus c. And then we can look at it as the two pieces, the opposite piece and then the x minus c piece. If you have a number in front of your function, you're going to either stretch or compress your function depending on what number it is. If that number is larger than 1, it's going to stretch your function, versus if it's a number between 0 and 1, it's going to compress it and actually make it more wide. So vertical stretch is almost making it more narrow. Vertical compression is more wide. And then I don't think we talk about this one here, but if there's a number in front of the x like this, you're going to horizontally compress or stretch the function. So these are going to be multiple choice, and you have to describe what is happening to the function if I give these transformations. The original function is f of x, and we want to talk about what happens if I do f of negative x plus 6 minus 3. So what I said is we have to make sure that if we have a negative x, we write that a little bit differently. So this is actually f of the opposite of x minus 6 and then minus 3 on the outside. So we have to do it in 3 parts, in steps. You can't have a negative x plus 6 and just say, oh, that's a flip and a left 6, because it's actually not. We have to negate the whole thing inside so that we can see which direction we're moving correctly. All right, so then I go piece by piece. I know that this negative here is going to flip over the y-axis. This is now a positive x. Minus 6 means I actually move right 6 inside of the parentheses. And then a minus 3 on the end is down 3. So I'm looking for the one that lists we flip over the y, go 3 units right, and then down 3 units. And that is option choice B. Let's look at the next one. Again, our original function is going to be f of x, and this is our transformation here. 4 times the function x minus 3, and then add 6. So working piece by piece, a 4 outside of the function, because that's bigger than 1, is going to stretch our graph. Inside the parentheses, if it's a subtraction, it's moving right, the opposite of what it looks like. So right 3. And then a plus 6 on the end is going to shift us up 6. So we're looking for a vertical stretch, shifting right 3, and then up 6, and that is answer choice D. Next one does the transformation 3 times the function and then adds 2. And the number in front of the entire function, if it is greater than 1, is going to stretch the function. So we are stretching the function, and then we have a plus 2 outside on the end, so that's going to go up 2. So vertical stretch and then shifting up 2 is A. Next one, the graph of the function f, open parentheses, negative x plus 4. So again, that's that one that we can't just have negative x plus a number inside here. We have to rewrite that as the opposite of the quantity x minus 4. It always has to be the opposite of a quantity. We can't just have negative x and then plus something. So that negative here is a flip over the y-axis. And then this minus 4 means we're moving right 4. The one that says we flip over the y and then goes 4 right is answer choice C. Number 5, the function of y equals negative 1/2 times f of x minus 2 minus 7. This does a whole bunch of things. So first thing we see is a negative outside the front, and the negative outside the front is going to be an x-axis flip. The number out front is between 0 and 1, which means we're going to then compress and not stretch. Inside here, minus 2 means I actually move right 2. And then a minus 7 outside means I'm going to move down 7. So we're going to flip over the x-axis, compress, go right 2 and down 7. And that is answer choice A. Now we're going to actually graph some of these transformations. So if they give us our original function as a graph, we are going to show how it actually moves on the graph. The given function is graphed here, and we want to find the new function f of x minus 3 and then plus 2. What this means is here, this is right 3 and then up 2. So basically every nice point that I have on this graph, I need to move right 3 and then up 2. So if I'm going to start with this point, I'm going to move it right 3. 1, 2, 3, up 2. And then I'm going to do the same with the next one. 1, 2, 3, up 2. 1, 2, 3, up 2. And this one here, 1, 2, 3, up 2. And then you should see or be able to see that it's going to continue going up like this. And here is our new function. Every single point is shifted right 3 and up 2. So another thing they can do is give us a point and then tell us or ask us what ordered pair will be on this new graph. So we have a point 3, 4 on the original graph, and we're going to go through this transformation of f, x plus 5, and then minus 1. What this tells us to do here is move left 5 and down 1. Well, left 5 is impacting the x coordinate. So the x coordinate, we need to take away 5 because that's how we move left 5. And in the y coordinate, we need to subtract 1 because then in the coordinate plane, if we go left, we're moving negative. If we're going down, we're moving negative. So if I take my original x, 3, subtract 5, that's going to make the point negative 2. And the y currently is 4. it says we're going to move down 1. So if I subtract 1, it's going to have us at 3. So negative 2, 3 is going to be on our graph. If negative 6, negative 8 is a point on the graph, what ordered pair will be on the graph of the function x minus 3 and then plus 4? So minus 3 inside means I want to move right 3, and plus 4 on the outside means I want to move up 4. That means to my x coordinate, I need to add 3, and to my y coordinate, I need to add 4, because as I move right, I increase my values on the coordinate plane, and as I move up, I increase my values as well. If I take negative 6 plus 3, that's going to give me negative 3 for my new x value. My y value was at negative 8, and I want to add 4 to that, so that's going to make us at negative 4 now. Next one, we have a graph again. This is the same graph that we started with for the first problem, and it now wants us to ask us, what is the graph going to look like if I do the negative of the function? So the negative outside means I'm going to flip over the y-axis. Or I'm sorry, flip over the x-axis. Sorry, I wrote the wrong one. Flip over the x-axis. This is the x-axis here. So my graph is just going to be reflected or mirror imaged on the bottom. So I'm going to, instead of going up like this, I go down. And then this one was up 1, so it's going to go down 1. 2, it's going to go down here. So I'm just making the mirror image of the graph. If I were to fold the paper on this line, the two parts would lay on top of each other. If we have the point 2, negative 7 on the original function, what ordered pair is going to be on this graph, f of negative x? Well, negative x, like this, is a flip over the y-axis. So if I visually think about that, I'm here at positive 2 and down here at negative 7. If I want to flip it over the y-axis, which is this one here, I'm going to mirror it 2 units this way. So I'm 2 units from the line, 2 units this way. I am just negating the x. So negative 2 is going to be with negative 7 now. We now have a parabola here, graphed, and it now wants us to find what is y equals 2 times f of x. So what this is saying is we want to times all the y values by 2. Because f of x is y, so we're going to take all of the x's stay, we're going to look at the y's. So this point here is negative 2, positive 2. I want to times the y value by 2, so it's going to be negative 2, 4. Negative 1 is at negative 1. If I want to multiply the y value by 2, it's going to be negative 1, stays the x value, but the y value is now going to be negative 2. So I'm not going to be down here. And then I have this point here, 0, negative 2. I want to multiply the y value by 2. So 0 is going to stay as the x value. The y value is now going to be negative 4. So that's going to be down here. And then it's going to repeat on the opposite side. So symmetric there, and then symmetric here. So my new graph is going to be the blue one. What if they give us the point like this? We have 4, 6, and they want us to find an ordered pair such that y equals f times 2 of x. So in this case, what we need to do is think a little bit backwards. We have, if I look at this, if I plug in 6 here as the y, 6 equals f of 4. We know that to be true. That's the original information. 6 is equal to the function evaluated at 4. But now what I want is 6 to equal the function 2 times x. So we want to know 2 times what gave me 4. Well, x would have to be 2 in order for that to work. So 2x equals 4, x would have to be 2 in order to keep the y value the same. So 1 point could be 2, 6. So what this is saying is you can keep the y and you need half of the x in order to keep the y. Y equals the function 2 times x means I'm doubling the x to keep the original y, which means I need half of the original x. We have an absolute value graph, and what they want us to do this time is do -2 times the function and then add 3. So what that means we have to do is to change the y. The x's are not changing. F of x. So x does not change. X stays as is. To find the y's, you're going to take -2 times the current y value and then add 3. All right, so if I look at this point here, I'll start with this guy here, -2, 1. So we're going to stay -2. So -2, 1, it stays -2, but the y value has to be times by -2. So 1 times -2 is -2. And then I'm going to add 3 to that. And that is going to give me 1. So that point actually stays right where it is. This point here, -1, 0, is going to stay -1, but let's do the y. -2 times the y, which is 0, plus 3 is 3. So -1, 3 is my new point. Okay, I have this point down here, 0, -1. The x value stays the same. We're going to multiply the y, -1, by -2. So that's going to give me 2, to which I add 3 is going to give me 5. Now, we know this is an absolute value graph, so it has to match on the other side. So if I have 1 point to the v, I can just reflect the other points here, mirror them down to get my new graph. If 3, 3 is a point on the original function, what ordered pair must also be on the graph? If this is our graph, y equals f of 3 times x minus 6 plus 4. All right, so one thing we can do is we can keep the x value the same and just plug in here and see what happens. So if we keep x equal to 3, well, f of 3 times 3 minus 6 and then plus 4. So we get 3 times 3 is 9. 9 minus 6 is 3. So f of 3 plus 4 is what we want. Well, f of 3, we know from here is 3. So the original function, f, if I plug in 3, gives me 3. So 3 plus 4 is going to give me 7 if I use x equals 3. So my new point is 3, 7. The last little part here is about odd and even functions. So we are going to look at some equations, determine if they're odd or even, or in fact, neither. So even and odd functions. In an even function, if I am to negate the x and evaluate, I get the same value as if I had just used the original x. So these are going to be symmetric about the y-axis. Odd functions, if I plug in negative x, I get negative y. I'm going to be symmetric about the origin. So looking at graphs, an even function like this is symmetric about the y-axis. All right, so I have the low point here, and then I mimic everything or mirror everything on the other side. Even functions have all even powers. So x squared, x to the fourth, that makes them even. Odd functions are straight lines like this, or we can get into odd powers, and then they look like this. So what's up here is now reflected down here into the opposite origin, or sorry, across the origin symmetrically. Odd functions are going to have odd powers. X cubed, x to the fifth. In order for it to be odd, they all must be odd powers. In order for it to be even, they all must be even powers. If there is a combination of even and odd, we do not have either, so we would say neither. Looking at this first one, we're going to determine whether they are even, odd, or neither. So we have x cubed plus x. Looking at the powers, I have a power 3 and then an invisible power 1. So the one, if it's not written, it's power 1. 3 and 1 are both odd. So this graph is odd. When I look at b, I have an x squared plus 7x, which is going to be a power 1, and then plus 10. So I have an even power and I have an odd power. So if they're combined, I have a neither. I do not have any form of that symmetry or reflection. Continuing on here, we have 3 more examples. X to the third minus x. You'll see that both powers are odd, power 3, power 1. So the overall graph is odd. B, 2x squared plus x to the fourth, power 2, power 4 are both even. So the end result is even. And then the last one, 3x squared, so an even, minus x, which is an odd. Combine them together is going to make a neither. They need to be all even or all odd to be even or odd. And that is the end of that section, and you can go on and complete the homework.